All right, so we're going to do some more reviewing. We're going to do solving one-step equations that contain addition and subtraction. So let's start out with the equation x plus 6 equals 15. And we're being asked to find the value of x. So our goal is to isolate that variable, the variable being x, and getting all the constants, which are 6 and 15, all together on one side of the equation. So we're going to do a little hanger diagram here to help you see it. So I have x on this side, and then I have 6 here hanging with x, and then on the other side I have 15 hanging. And they are balanced because it says it's equal, but I need to get this x all by itself. So what I want to do is I want this to go away. So what can I put with positive 6 to make it go to 0? Well, if we think about 0 pairs, they equal 0. So what is the opposite of 6? Well, that would be negative 6. So if I put negative 6 on this side, to keep it balanced, I have to put negative 6 on this side. So now these cancel each other out because they're a 0 pair. And then we're going to do 15 plus negative 6. So the signs are different. So we're going to subtract and we get 9, and there's more positives. So this becomes 9. So now what we have left is x equals 9. So that's using a hanger diagram. To do it mathematically with the equation, I always draw an upside down T at the equal sign so that I can see both sides of the equation. I'm looking over here and I'm saying, what's hanging with x? Well, 6 is hanging with x. How do I make 6 go away? I'm going to put negative 6 with it. To keep it balanced, I have to put negative 6 on the other side as well. 6 and negative 6 cancel each other out, so I'm left with x on the left-hand side. And on the right-hand side, 15 plus negative 6 is 9. Now I can go back and throw this back into the original equation. So if x equals 9, 9 plus 6, does that equal 15? Well, 9 plus 6 is 15, and that equals 15. So we end up getting 15 equals 15, and it checks. All right, so let's try another one. So we have x minus 3 equals 2. All right, so let's visualize what that would look like on a hanger diagram. So we have our x, and now we have, this isn't just 3 because this goes to that, because this becomes x plus negative 3. So we're going to add on a negative 3 here, and then on this side we have 2. Well, my goal is to get x by itself, so I need this negative 3 to go away. What am I going to put with negative 3 to make it 0? I'm going to put its opposite with it, so the opposite of negative 3 is positive 3. If I put positive 3 on that side, I have to put positive 3 on that side to keep it balanced. These cancel each other out, and now instead of 2 here, I now have 5. Okay, so x equals 5. I have isolated the variable. So if we go to the equation, we're going to draw the upside down T at the equal sign. We've got x here, and what's hanging with x? Negative 3 is hanging with x. So I'm going to put positive 3 with it. It's opposite. If I do it on one side, I have to do it on the other side. So now I have negative 3 and 3 make 0. They cancel each other out. So I'm left with x here equals 5. Let's check it. Let's go back to the original equation. Remember, the original equation was x minus 3 equals 2. So let's do 5 minus 3. Does that equal 2? Well, 5 minus 3 is 5 plus negative 3, which will equal 2. And last time I checked, 2 equals 2. So we have done it correctly. All right, let's look at another one. So this might confuse you a little bit. So now we have 14 minus x equals negative 2. Let's draw it and see what it looks like. So we have 14. Hanging with that. Now remember, this goes with this, so copy, change, opposite. So we don't have positive x, we have negative x. And then on this side we have negative 2. All right, our goal is to get x by itself. So we have x here. This needs to go away. This 14 needs to go away. So let's do the opposite of 14 is negative 14. If I do it on this side, I have to do it on this side. All right, so those cancel. And negative 2 and negative 14 make negative 16 over here now. But now I'm left with negative x equals negative 16, or the opposite of x equals the opposite of 16. Well, I want to solve for positive x. I don't want to solve for negative x. So if I have negative x here, to turn it into positive, I can just think of the opposite of negative x is x. Well, if I take the opposite of this, I need to take the opposite of this. So what is the opposite of negative 16? Positive 16. Now mathematically what we're really doing is we're multiplying both sides by negative 1. But it's a quick think of this means the opposite of x is negative 16. So x, which is the opposite, what's the opposite of negative 16? 16. So let's look at it using the equation. So what's hanging with our negative x? Well, 14 is hanging there. What's the opposite of 14? Negative 14, because we want it to go away. So that becomes 0, it goes away, and we're left with negative x equals negative 16. And remember, we don't want to solve for the negative variable, we want to solve for the positive variable. So if the opposite of x, so let's take the opposite of that, would be x. Now take the opposite of that would be 16. So our solution is 16. Well, let's go back to the original equation and see if it works. So we're going to plug in. So we got 14 minus 16. Does that equal negative 2? Well, we remember copy, change, opposite. So this becomes 14 plus negative 16. The signs are different. Now I'm ignoring this right-hand side right now. I'm only solving this left-hand side. Signs are different, so I'm going to cancel or subtract. 16 minus 14 is 2, and there are more negatives than there are positives, so I get negative 2 on that side. And is that what I needed? It sure enough is. So I have done the problem correctly. So I hope this helps you with remembering how to solve one-step equations that contain addition and subtraction. It all goes back to what we learned: change all subtraction to an addition problem, and then think about what's hanging with x and how do I make it go away? I use the opposite. So I hope we grew your math brain today.